Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Space has become a critical warfighting domain, requiring an approach to training that prepares warfighters to use new technology. AI is redefining space warfare training and is becoming vital for deterrence and national security. Slingshot Aerospace is a U.S.-based space data and analytics company focused on making space operations more safe, sustainable, and secure through satellite tracking, space traffic coordination, and high-fidelity modeling and simulation tools. What does all this signal for the future of AI-enabled military training? My guest on this edition of the Journal of Space Commerce podcast is Dr. Belinda Marchand, Chief Scientist at Slingshot Aerospace, leading astrodynamics and data science teams that build foundational capabilities for its products. And Belinda, thanks for joining me today.
My pleasure. Thank you for having me.
Let's start out kind of from ground zero. What was missing in traditional space warfare training, and how does AI change that dynamic?
That's a great question. So if you kind of look back at the history of how, training has proceeded in the past, it was usually based on a set of scripted tactics or scripted scenarios. And that didn't really take into account readily the evolving nature of the space environment, the evolving nature of the threat, and having to adapt became a very manual and heavy lift. And so you're seeing now a shift away from that because the environment is not only increasingly congested, but also evolvingly and increasingly dynamic. The capabilities that are going into orbit are accelerating rapidly. And as a result of that increased level of agility and increased level of capability, the threats in orbit have become intelligent and challenging to address. And so the training environment has to adapt to that evolving threat. And also our capabilities have to adapt with it as well, because once you're in orbit, you have to be able to respond.
How is the AI that you're using different from the AI that so many of us use kind of now almost every day in our business? I'm sure you're not using ChatGPT to do all this.
No. So ChatGPT and similar models, those are basically large language models. In a sense, you have a conversation with a large language model, and it is giving you almost like a statistical representation of what the most likely answer is. It's very different from what we do. What we do is we have an agentic AI framework that is built upon realistic physics models to inform actual responses that obey the laws of physics, that obey the constraints of the systems that we're flying, that is informed by actual data streaming into the platform and actual decisions streaming into the platform, so that those agents can make intelligent assessments and intelligent decisions informed by that physics and rooted in those constraints.
How has Slingshot evolved from its kind of original concept to what you're doing with the space warfare training? I mean, you started out with just basically tracking objects in orbit, and now you're training for space warfare. How did that evolution occur?
It actually started even before that, because in the beginning of our journey, of course, if you're familiar with our co-founders, two of them came from that military side of the house, the space operators. And so they set out to, build capabilities that would empower the warfighter to achieve its mission and to achieve it optimally. And when we started, we began by applying like AI technologies and modeling and simulation based on the data that we had access to at the time, which wasn't our own data. It was data that was made accessible to us through the government to do analysis and analytics and simulation. And in 2022, we acquired two companies that became the game changer for that and enabled us to do other things. One was a company that gave us access to our own space object tracking data source, our own globally distributed network of optical systems. And we have expanded that network and its capabilities since. The other was the largest database of contextual space object data. And basically think of that like physical attributes, trends, anomalies, things like that, about everything that's ever gone into orbit since the launch of Sputnik. Those two acquisitions empowered us to do something very different than what we did before, because now we became the source of the largest source of the data that we were using to train. We could augment it with third-party sources, but we were no longer dependent on them. And because this information allows us to track the space object populations and its anomalies and its trends and behaviors, that enabled us to train more realistic AI agents to accomplish specific missions. And that was the beginning of that journey into agentic AI and wargaming and training and simulation for Slingshot. The reason we can do it as well as we do is not just because of the modeling and the AI, but it's also because of the data that empowers us to do that.
Talk to me about Slingshot's platform and Talos in kind of, if you can, in non-technical terms.
Yeah, sure. So Slingshot platform, versus Talos. The platform, or we call it now the portal, it's more of the jump off point for how you access and interact with Slingshot's data and data products and modeling and simulation. It's like an integrated ecosystem. Talos specifically, it's meant to mimic the human decision process, the commonly known in the military circles as the OODA loop: observe, orient, decide, and act. Right. So what Talos does is it mimics that sort of higher level thinking, and it observes. That means it's taking in data from different sources. That could be space object tracking data. It could be derived information from that data. It could be open source intelligence. It could be data from other providers. It's taking all the information that it has available, and it's making in a loop and constantly reassessing the evolving situation in space to determine, how does this information impinge on my assets, and what should I do about it? Right. And you can use that Talos system to give you either a recommendation on what to do, or you can let it drive your satellites, whether your satellites are actually just synthetic representations in a simulated environment, or they're the actual real satellites that are just connected through an interface to Talos. Talos is basically able to do either one of those two things. Either it recommends you what you should do, or it could potentially drive your satellites as well, or drive them in simulation.
So then how do you train an adversary in orbit without access to real-world conflict data?
Well, you don't train the adversary. Let me correct that statement. You are training agents that represent or mimic the behaviors of an adversary. And that training is informed by the data that we collect, which is, what can we do today? We never really know exactly what's happening inside the satellite. What we can do is observe its actions, observe its behaviors. And now those behaviors may have multiple reasons, right? You never really know the reasons because you're not in the mind of the opposing operator, but you can observe and just watch over time and see what it does, and see what might be prompting those actions, what might be its next targets based on its past behaviors. What size of maneuvers is it capable of doing? How big of an orbital change has it been able to affect historically with each of these actions that it has taken? So you take all that information and you build it over, months and years, and that can then be used to inform the training of AI agents that also leverage in combination physics models to fill the gaps in between of what you cannot observe. Because ultimately, everything that's in orbit is subject to the laws of physics, right?
So then take me through just kind of a basic training scenario. What do the people that you're training see when they sit down in front of the system, and what are they looking for? What are you trying to have your system teach them to recognize?
Yeah, so usually in the case of, let's say, a wargaming type exercise, you have the good guys and you have the bad guys, and there may be some neutral parties in the middle, right? And so you have forces that represent each, guardians on one side, guardians on the other side, almost like in a sense of a video game, right? But many players. Each player is usually responsible for an asset in orbit, sometimes multiple players can be responsible for different functions of that asset. So in the case of the aggressors, for example, they would be in control of the thing that mimics the adversary in the traditional way. An actual human would be flying that digital representation of the adversary, while actual humans are on the other side of the equation, driving, so to speak, the good guys representation in that digital environment. So you typically will have something like a common operating picture that is ingesting data from different sources, and the actions of the entities in the simulation are driven, to quote an old example for those who ever played Pac-Man, are driving the joystick, so to speak, on what that object is doing. That's a severely oversimplified statement, but indulge me on that one. Effectively,
you're almost dating yourself about Pac-Man.
I know. But anyway, so each human basically is either responsible for all the actions of a single asset, or multiple humans could be responsible for different aspects of the decision-making process of that asset. And that's how it's kind of done today. Now, usually, you also have in training settings, you have a white cell, which is like the instructors, right? And so because real space flight is an inherently discrete information environment, meaning you don't always know what the other guy is doing. You have gaps in your knowledge. You see them now, then you don't see them for a while, and then you see them again. Then you don't see them for a while, and then you see them again, right? So the white cell can control the flow of information, and as well as the all of a sudden something happened. You don't know when it happened, but it happened, and now you got to go deal with it, right? And so that's kind of how it's historically transpired. As we move to accelerate the capabilities and work towards being able to provide that dynamically evolving threat representation, that sort of human in the middle process doesn't work very well, right? And so that's where the ability to leverage artificial intelligence to make really rapid adaptations informed by the data can help in environments like that.
Belinda, where do you see the defense of intellectual property in this space? Is it in the data ownership, the sensor networks, the simulation engine, the AI models, all of the above, or something that I've missed?
You repeat that question real quick.
I'm talking about the intellectual property. How do you defend what it is that you're building, and where do you see the primary IP in that space?
Yeah, so a key ingredient, and it's probably a more important aspect of all this. There's a lot of players in the domain that will either focus on, let's say, the physics modeling and simulation, or that might focus on the AI side. Others that become the data source. And so, but being your own source, your own comprehensive source of data, that is very defensible, especially if the data that you own is very high value in terms of what it reveals about the adversary, right? So you want rich data sets that you can derive multiple insights from about the adversary's behaviors and trends, and then use that to train your AI. Now, whether that comes from source A or B, or whether the physics models come from C or D, doesn't really matter, right? You want to create a platform that can work with any model, that can leverage any AI models, especially as they continually evolve, informed by that data, right?
Mm-hmm. I'm talking with Dr. Belinda Marchand, Chief Scientist at Slingshot Aerospace on the Journal of Space Commerce podcast. We'll take a short break and be right back.
You're listening to the Journal of Space Commerce podcast from Xterra Media. The Journal of Space Commerce is the only industry publication to offer in-depth coverage of the entire space commerce value chain, from the supply chain to satellite operations and terrestrial applications. If you're a decision maker or investor in the space commerce industry, or an executive who needs to know how space commerce touches your business, please consider becoming a paid subscriber. Of course, everyone is welcome. Your paid subscription will give you first access to premium articles and podcasts focused on the space value chain. From market analyses to regulatory developments and company spotlights, paid subscribers will find valuable data to help you make informed decisions. Just visit www.xterrajsc.com on Substack and help keep the Journal of Space Commerce the industry's only independent source for space commerce intelligence for business leaders.
Welcome back to the Journal of Space Commerce podcast. I'm Tom Patton, and I'm talking with Dr. Belinda Marchand, Chief Scientist for Slingshot Aerospace. Belinda, let's talk about your work with the U.S. Space Force's OTTI and the UK Space Agency. What do these partnerships say about how commercial AI and SDA are being integrated into national systems?
So both of those, they tackle, different parts of the, let's say, the decision chain. You have to have data in order to make intelligent decisions, right? So the UK effort, we're an optical systems provider. So we are helping them build their own sovereign network by deploying optical systems that are the source of that data. The OTTI effort is more about advancing the training and testing simulation infrastructure that supports Guardians today by bringing in a system that can interact with the existing capabilities, as well as introduce AI into that workflow to help accelerate decision making, to provide intelligent representations of autonomy and orbit, to provide realistic adversaries in those synthetic engagements, and so on. So they're very different efforts. But if you think of it holistically, in practice, to get to a point where Guardians can, train like fight like they train, basically, right? You want to be able to train exactly how you expect to operate later on. So in order to enable that, you have to have the entire chain. You have to have the data that would inform those decisions. You have to have the systems that enable you to pull in that data, that enable you to pull in the models that you need, and that then inform those decisions so that you can use it both in that training environment, you can use it in the test environment if you want to later in a live test, and then you can do it in practice and operations as well.
Sitting here thinking, because so many of our satellites right now are what I would call benign for the most part. They're not adversarial to one another. So does your AI assume that whatever enemy it's going to be has created some kind of an adversarial satellite that can attack either one of our space assets or attack the Earth from space?
So it's interesting because I have to kind of correct part of that statement. There are a wide range of activities in orbit that can be representative of adversarial behaviors, even if they're not causing damage, right?
Okay.
So adversarial doesn't mean you damaged my satellite, you destroyed my satellite, or anything like that. It could just equally be the provocative exercise of capabilities to suggest what you could do, right? That is also adversarial in nature. And we see that all the time with our sensors. Things happening in orbit that are certainly not things you would do if you're friendly, right?
Right.
So that can encompass any number of things. We see examples, and often in our press releases, you'll see examples of things that like to perch themselves next to you and eavesdrop, or that might be doing proximity operations about another nation's assets. Why are you doing that? Right? What is the nature of the reason for you to do that? That are demonstrating exercises with themselves, which could be construed as, well, you could be doing a demonstration of on-orbit servicing, you could be doing a demonstration of refueling, or you could be doing a demonstration of grappling and taking something out of its slot and, right? So even the demonstration of provocative behaviors is itself adversarial in nature.
Let's talk a little bit about export controls and classifications and some of the things that you have to be concerned about, and connect that with the emerging AI in defense policies. And how does that shape what you can build and where you can deploy it?
Yeah. So in terms of classification, right, you have the restrictions that affect, which data can be used, who can use it, where can it be processed? That's one aspect. Then you have export controls, which relate more to, how you can leverage those same technologies or that even that data for the benefit of another nation. And then you have the responsible sort of AI policy side, which is sort of an emerging topic right now, more so than regulation. The classification side of the house, that's something that anybody who's playing in the domain, so to speak, commercially, you have to adhere to those restrictions because that's just a function of you want to use my data. This is what you're allowed to do and not do with it, and this is how you have to handle it, and so on. And so we've recently, I don't know if it was yesterday or today, there was an announcement about our CMMCL2 certification. That's an example of us taking the steps necessary to achieve in the customer's realm that level of confidence that we are being careful with the data that you entrust us with to provide you the services that we provide you. And expert controls is going to relate more to can we use this specific technology or this specific data product for service of this other country? And that's a question that it's an everyday thing. Every time we try to sell something, for instance, you have to think about those things. Is this something that I am allowed to share? Is this something that I'm allowed to sell based on the restrictions on the data that informed that capability?
Let's talk about that CMMCL2 certification, because I did get that news release came across today to me. What is that and what does it mean?
Yeah, so basically it's kind of a requirement that the government imposes now. It didn't used to be the case, but now it's being required for anybody that's handling compartmented unclassified information, right? So if the government's going to trust you with this kind of information, then you have to demonstrate that you check all these boxes so that I know that you're being safe with this data. And it used to be that this wasn't necessarily required across the board. Now it's required. And so being able to demonstrate that you've checked that box is a big step in the evolution of a company towards being able to play in a bigger field with other contractors that are more government-centric.
How do hardware partners and sensor operators kind of fit into your model, and what does it take to stand up a sovereign space defense SDA network for a country? What does that include?
Yeah, so standing up a network, it's more than just slapping a sensor on the ground, right? Just because you have a sensor doesn't mean you magically derive information about where everything is and what it's doing. You need the hardware configured in the right way. You need software that both locally and sometimes, depending on the amount of data that you collect, sometimes in the cloud, but you need software that can be used to command and control the system remotely, especially in the case of distributed networks. You also need software that can do the processing of the information those sensors collect to extract insights. And the more data the sensors collect, the more complex and large that operation becomes, right? So you need sensors, you need command control software, you need data processing capabilities, and then you need the secure infrastructure to handle that data if the information you're collecting is on a sensitive object or of a sensitive nature. Then you have to demonstrate that your entire data pipeline conforms to the standards that the customer requires.
I had kind of a little senior moment, and I should have known that was space domain awareness is what SDA is. It just didn't didn't click in my brain for just a moment. But that brings to mind, does your AI model, when you're talking about training for defense, does that include the space domain awareness data that you might be able to collect from tracks or other commercial kinds of providers of that information?
Yeah, so our network specifically, the data that we collect that helps us train our AI, it's just monitoring everything, right? If you look at our optical fence technologies, those systems just stare at the sky, and if you cross in front of them, they're going to see you, right? Whether you're military or commercial or you chunk of debris, it doesn't matter. So we leverage all that data, whether it is for the specific use case of developing AI for training and wargaming, or it's to develop products to enable autonomous operations or other types of anomaly detection, things like that. That's separate from the data itself. We can use that data. We can use external sources of data to augment that information as well. But depending on the source of information that you might choose to augment with, that might restrict the use case. So if, for example, we're using government data in a processing chain to help inform a product, that might restrict whether that product is only used by the government or not.
Then how
Depends
much
on
of
the
your
information.
then how much of your technology is dual use for other areas of the company that are not necessarily involved in defense, that are more involved in the SDA side of the house?
Pretty much all our technology is dual use because
Or more, I'm sure.
the interface point is with the data. Now think of it like an electrical outlet on the wall, right? I can plug different lamps into that outlet. And so one of the things that I plug into my tool might be my own data from the network. Well, I own that data. I can do whatever I want with that data, right? But you might also plug in other sources of information into that same tool. That doesn't make the tool unique to that customer. The data stream that feeds the tool might be unique to that customer. So, for example, let's say that we're deploying Talos, our agentic AI technology, into a testing and wargaming environment of the customer's choice. The technology itself is the same, but it might be used to be trained on different data sets. The resulting agents might then become only accessible to that customer because we trained it on restricted data. But we built that framework in the unclassified side of the house with our own data that we own. And therefore, the framework itself is not subject to those things.
If we were going to sit down again in 5 years, how would you like the space community to describe Slingshot's role in shaping deterrence and training for conflict in orbit?
The company that pioneered agentic AI for training and wargaming at scale. And that's kind of a key thing. AI is used for a lot of things today, and there's a lot of different players that own different little pieces, I think, of the puzzle or demonstrate capabilities in different little pieces. The things that we do it at a scale that others don't, precisely because we see everything with our systems, right? So we're not just trying to fly one thing. We can help you fly many things in an environment that many other things are impinging on you at the same time, and sometimes leveraging things on the ground and other sources of information. So it's this whole ecosystem that enables you to fly or train or test as if you were really up there, impinged upon by all the things that are really up there.
That being said, then, what guardrails do you think the industry needs to have around AI behaviors in simulated conflict?
Yeah, I think in that regard, remembering that space is a shared environment, right? So you not only have the good guys and the bad guys, you have the bystanders. So it's kind of, in a way, it's kind of similar to being on the ground and having the police force on the ground. You don't just shoot indiscriminately if there are other people in the way, right? So it's like, how do you leverage the technologies that you've built and incorporate intelligent policies that allow you to achieve your mission successfully without sacrificing the guys in the middle? That's where you need to see that change.
And then do you see spin-offs into other areas like commercial fleet management or insurance or other things that need this kind of simulation? Does it stop at defense, or are there commercial applications as well?
That's a great question. And no, it does not stop. So I think the defense use case was a very valuable and timely example of a way to demonstrate the capabilities of the technology. But the technology itself that powers things like Talos, or even that powers our anomaly detection software like Agatha for anomalous actor detection, all those technologies can be used for other purposes as well, right? You can use them to fly your fleet, to control your fleet, to achieve your, on-orbit servicing objectives, anything that involves rendezvous proximity operations. You could adapt. If you're doing RPOs for intercepting something, that's not that dissimilar from the type of activity you would do to go service something or refuel something, right? Or to do in-orbit manufacturing and things like that. So the actions have elements in common, and the framework itself is agnostic to those actions. In the case of anomaly detection, right now we use that same technology to track anomalous actors, but that same technology could help you figure out, hey, there's something funky going on with your asset. You might want to go check on it. Or it might be used on board to help you identify anomalous streams of data that might suggest somebody's trying to, impinge some kind of interference attack, or maybe you're losing signal or something is degrading within your system. Those are all data streams that can be subject to the same kind of anomaly detection that we use today for anomalous actor detection. So all the technology is ultimately dual use. It's just how you choose to use it.
Belinda, we are out of time, but I really appreciate you taking time to talk with us today on the Journal of Space Commerce podcast.
It's my pleasure. Thank you for having me.
Dr. Belinda Marchand is the chief scientist for Slingshot Aerospace. And that's going to do it for this edition of the Journal of Space Commerce podcast. I'm Tom Patton. Thanks for joining us.
The Journal of Space Commerce podcast is a production of Xterra Media. The executive producers are Mike Turner and Tom Patton, with production assistance from Debbie Turner. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so that you don't miss any of our podcasts or any of our other videos. The Journal of Space Commerce is the only industry publication systematically covering the entire space commerce value chain, from the supply chain to satellite operations and terrestrial applications. If you're a decision maker or investor in the space commerce industry, or an executive who needs to know how space commerce touches your business, please consider becoming a paid subscriber. Of course, everyone is welcome. Your paid subscription will give you first access to premium articles and podcasts focused on the space value chain. From market analyses to regulatory developments and company spotlights, paid subscribers will find valuable data to help you make informed decisions. Just visit www.xterrajsc.com on Substack and help keep the Journal of Space Commerce the industry's only independent source for space commerce intelligence for business leaders.
I wanna go faster, hands in the air, we're gonna crash. Searching for the answers, my Galileo, the proof is looking glass. That's for reason. Our dreamer's eyes we gaze into, a sense of purpose, know my view. Like finding water on the moon.